This will be the second video on normal distributions. If you've not seen the first one and want to see an introduction, then have a look in the playlist. But this one is going to look at ones where we don't know either the mean or the standard deviation. So this one, I'm going harder. I'm going for one where we don't know either of them, but the same sort of approach will work if we don't know just one of the two, but we'll need less information to solve it. So in this case, we're looking at a certain component that needs to be made for an engine, and we're told that the time taken to make these components is normally distributed. And then we're told two things. We're told that it takes over 90 minutes for Sheila to make these components only 10% of the time, and we're told that 20% of the time she takes less than 70 minutes. And we're asked to try and estimate the mean and standard deviation from this information. Now, I would recommend always starting by drawing a little picture of your normal distribution, of your bell curve, labeling that on, and then we can use that to try and go from there. So we've got our bell curve here. That should be a little bit more symmetrical, but I'll go with that. It's going to be good enough for our purposes. And we're told two things here. We're told 90 minutes, she takes more than that length of time, 10% of the time. So I'm going to label the right-hand area as 0.1. And we're also told that she takes less than 70 minutes 20% of the time. So that's clearly going to be below the mean if she's doing it 20% of the time. And the area is 0.2. And we've got 70 there. So we're trying to work out the peak here, the mean. Now, I'm going to use mu to represent the population mean here, which is what we're trying to do, the mean of all the time she makes a component. I'm going to use sigma to represent the standard deviation here. So the first thing I want to do, I want to look at this 0.1, this 90 minutes and this 0.1 first of all, and see what we can do with this information. Well, we know that if there's 0.1 to the right, there's 0.9 in terms of area to the left of that point. So if you go to your inverse normal distribution, because whenever we're told an area, we want to be working with the inverse normal. So go to your inverse normal, say your left-hand area is 0.9. If your calculator is one of the graphical ones, you might be able to say your right-hand area is 0.1. It will do exactly the same for you. And then it's asking us for sigma and for mu. Now, we don't know sigma or mu here, so I just want you to enter sigma as 1 and mu as 0. That's what's in the introduction video I recommended anyway. This is the reason why we're getting this understanding now. So if you go for that, it's going to spit out an answer of 1.282. What that's telling you is that we must be going 1.282 standard deviations above the mean to get to a point where the area to the left is 0.9 and the area to the right is 0.1. So we can turn this into an equation involving mu and sigma. We know that mu plus 1.282 sigma must be equal to 90. Note, I would keep that 1.282 stored to more accuracy in my calculator, but I'm not going to write it all out here, but I don't want any rounding errors later on. So we've got one equation involving mu and sigma, but we've got two unknowns, so that's not good enough. Fortunately, we've got a second piece of information to work with. We've also got this 70 down here, and we know the area to the left of that is 0.2. So again, go to your inverse normal on your calculator, put in the left-hand area is 0.2, still leaving your sigma as 1 and your mu as 0, because if we do that, it will always just tell us in terms of standard deviations. So if you go for that, you should get an answer of negative 0.8416. That's not a mistake getting a negative here. The reason we're getting negative is because we're going below the mean. So we know that if we take off 0.8416, lots of the standard deviation, we're going to land on 70. So we can form a second equation. We're going to get mu subtract 0.8416 standard deviations is equal to 70. And at this point, your life's got a lot easier. You've got two simultaneous equations, you've got two unknowns, you've got a range of things you could do here. If you're feeling particularly lazy, you could go to your simultaneous equations part of your calculator. If you're feeling a little less lazy, you could add these two equations together and you'll get an equation just in terms of sigma. Either way around you go here, you should end up being able to solve now and getting that your sigma is equal to 9.42 and that your mu is oh sorry, my pen's just getting a little bit dodgy there. Sorry about that. I'll try that again down here. Sigma is 9.42 and mu is equal to 77.9. I don't know what happened with my pen there. That's 9. I'm going to write it down here because it seems to have gone weird. There we go. It won't write a 2 for me. There we go. So that's the way to go about it. Use your inverse normals, work out how many standard deviations above or below the mean those points are, form your equations, and then you'll be able to solve for mu and sigma. So if you're only told mu, then you'll only need one of these areas to form one equation in terms of sigma. If you're only told sigma, you'll only need one to find mu. In a case where you're not told either, you'll need 2 pieces of information, but you can go through like that. Thank you very much.